Today, I will show you how to use Flux tools by Black Forest Labs, which includes new models which let you take greater control of your image generations, similar to ControlNet, but with much more ease. I'll take you through the depth and Canny models, which are perfect for sketch to AI render workflows, or with much higher quality outputs. In addition, you'll be able to take simple masking screenshots and change these into realistic renders. These workflows are very useful in architectural design. First, to get the necessary models out of the way, go to the Hugging Face links provided below, and starting with Flux Depth, download this model. Just be aware that it is rather large, and you will also need to download this AE Safe Tensors file or your VAE loader. And then you'll need to do the same for the Canny model. These models go into your Company UI folders under diffusion models like it, and that downloaded Safe Tensor file will go under the VAE folder. Lastly, you will need the clip models. Download the ClipL Safe Tensor and the FP16. The FP8 is much smaller and runs faster, but at the expense of quality. So choose either one, and then add these clips to the clip folder. Finally, go to Company UI, open the manager, and press Update, and restart. Otherwise, this will not work. Rather than starting from scratch, you can go to this page, which has basic workflows for the Flux tools. Here you can find the Canny model. Simply drag and drop this into your canvas. If you have any missing nodes, you can update them from the Company UI manager, but the main two we need are the auxiliary ControlNet preprocessors and the RG3 nodes. I'll make some updates to this workflow to improve it, but the core principles are the same and quite simple, all starting with the standard K-sampler. The two main new nodes are the pix-to-pix conditioning and the Flux guidance. Let's start by updating the models needed. For both workflows, we will need a dual clip loader. So add the ClipL Safe Tensor and the FP16 clip. You can use the FP8 version if your computer is short on memory. We will start with Canny, so load the Canny diffusion model. Keep the weight as default. Then for the VAE, add the AE.safe tensors, which we downloaded earlier as well. I will make one more change by adding the ControlNet preprocessor and adding the Canny Edge preprocessor rather than this existing node. Then change the size to 1024. You can then delete this existing Canny node and then connect up this preprocessor with the other images. For our sketch, I'll try out the classic John Pawson living room sketch and add the prompt to make it look like a modern Japanese-style living room with wooden paneling. Now I'll update some of the settings, so increase the steps to 30 for higher quality, or add some extra time to generation. I use the DPMPP_2M, which is a good sampler. I'll keep the scheduler to simple and denoise at 1. Now when I generate, you will see this preview of the Canny preprocessor. This is a good indication of what the composition of your generation will be like. Maps with clear and simple lines generate the most accurate sketched images. If you have more messy lines, the AI cannot make sense of these areas, and it will be making guesses on these features. Once this is generated and gone through the K-sampler, you can see how closely it has followed the lines. Almost spot on in some places, such as the books on the table, and the sofa and the door handles. The quality is also much better than the original stable diffusion ControlNet renders from over a year ago. So we can do a better comparison. I will add the image compare.rg3. This can be also installed from the manager. I already have it here, so I will just directly add the image compare and connect up with the Canny map to the first image and the generation to the second. I will try this with a more artistic sketch of a city elevation and prompt a modern skyscraper at night at the city waterside to see how it will interpret the water I sketched out it. When I run this, the Canny preprocessor has picked the outlines of the buildings quite well, and even the window grid lines, so it should create a decent image. As for the water, it will be left to the creativity of the AI. Now that it is fully rendered, it is actually very impressive. The realism and vibrancy is actually quite incredible. If I go over to our compare node, you can see how well it follows the building outlines and even the windows. Those simple lines are added for the water reflection have been interpreted better than expected. So this is a good example how creative you can be with your sketches. Now I will take you through the depth model, great for taking conceptual massing screenshots and fully rendering them with little effort. We can use the exact same workflow, but simply switch the preprocessor to depth anything, and then load the diffusion model with the Flux depth, and that's it. Over in Rhino, I have a concept massing building design in a city represented by simple boxes. For the depth preprocessor, it is good at estimating distance, so it picks up volumes very well rather than details. I'll screenshot this, and then Photoshop change the resolution to be 1024 by 1024. I'll save this and drop it into the CompUI canvas. The prompt will be a sculptural office with glass and steel exterior, Tokyo in the background. When I run this, you can see how well it picks up distance and forms and curves. I'm actually surprised it picked up the small voids in the middle of the tower, as the pixel size is very small. If you do want these small details, I would recommend using the Canny method instead, and having an image with more finer lines. Let's see how this generates. This output looks amazing. The towers fit perfectly into the surrounding, and this does look like Tokyo. Even the reflections look realistic, and the curves are picked up perfectly. Surprisingly, even the voids in the middle here are interpreted as vertical walkways and escalators. So it has actually rationalized our conceptual model. Finally, as a bonus, you may want to upscale this to 4K, which can be done with the Ultimate SD Upscaler, and like usual can be installed from the manager over here. Search for Ultimate SD Upscaler and add it. I will also add another screenshot of a much simpler form to show you how well this depth model works in basic shapes too. Then this combines with the load upscale model. The model I'll be using is the 4x Ultra Sharp, which you can download from the Civet AI website. And this just needs to be pasted into the models and upscale model here. For the settings, I want to upscale by 2. So this will become 2048 by 2048. I'll keep the steps at 20, and I'll match the sampler and scheduler to what I used in the original image. Resolution will be 1024 by 1024, as this is the tower size. So when they are added together, they will make the 4K final resolution. Now just connect up the nodes to all the matching names, but conditioning, models, and so forth. Actually, on second thoughts, it is better to add the conditioning directly from the positive and negative prompts at the start, rather than from the pix-to-pix conditioning, since we don't actually need to condition the upscaler, just increase the resolution. Now we can generate. And now we have our first image generation, which is looking great, but I've forgotten to add a save image node, so the upscaler didn't run. I'll add that and try it again. This takes a while since it is rendering a few tiles, but in the end you'll have a 4K image, and in a realistic setting from a simple wide model screenshot. The massing has been followed perfectly here, and has done a decent job at the intricate glass details, which at the moment most AI diffusion models have difficulty with, but you can keep reprompting or try the Canny model. And there you have it. 2 simple workflows for realistic outputs from simple massing models or sketches. I recommend you try these out on your own designs. I'll see you in the next video. I'll go through in painting and out painting.